Hello my beautiful viewers, you are welcome to my YouTube channel Mathematics Made Easy. So in today's video we'll be solving this beautiful differential equation. So we can see that this is initial value problem, and in today's video I'll be making use of the Laplace transform in solving this beautiful equation. Okay guys, please, if you haven't subscribed to my channel, subscribe to my channel, like my videos, comment and share. Thanks guys. So let's dive into the solution. So here's the first thing I'm going to do. I'm going to take the Laplace transform of both sides. So if I take the Laplace transform of both sides, I'm going to have the following. So we have the Laplace transform of y prime prime minus y prime minus 2y, so which is equal to the Laplace transform of 0. And take note that the Laplace transform of 0 will surely give us 0. Okay, so we're going to have the Laplace transform of y prime prime. If you apply the linearity law of the Laplace transform, then minus the Laplace transform of y prime, then minus 2 multiplied by the Laplace transform of y, then everything is equal to 0. So we can call this equation 1. Now, this one I'm going to do next, I'm going to find the Laplace transform of y prime prime and the Laplace transform of y prime. So finding the Laplace transform of y prime prime, that's the next target. Then how do we find the Laplace transform of y prime prime? Now take note of something. I'm going to remind us the Laplace transform of the nth derivative. So the Laplace transform of the nth derivative, so this is equal to s raised to the power of n multiplied by the Laplace transform of f, okay? Then minus s raised to the power of n minus 1 multiplied by f of 0, then minus s raised to the power of n minus 2 multiplied by f prime of 0, then minus dot 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 raised to multiplied by n minus 1, then of 0. Okay, so in this case n is equal to 2, so the Laplace transform of y prime prime, so this will be equal to s raised to the power of 2, then multiplied by the Laplace transform of y, then minus s raised to the power of 2 minus 1 multiplied by y of 0. Okay, so minus s raised to the power of 2 minus 2 multiplied by y prime of 0. Okay, so then we're going to have the Laplace transform of y prime prime, so which is equal to s raised to the power of 2 multiplied by the Laplace transform of y. Okay, then we know that 2 minus 1 will give us 1, so minus s, then multiplied by y of 0, then minus s raised to the power of 2 minus 2. 2 minus 2 will give us 0, and s raised to the power of 0 will give us 1, minus y prime of 0. Okay, so we know the initial values, y of 0, which is 1, and y prime of 0, which is 0. So we are going to have s raised to the power of 2 multiplied by the Laplace transform of y, then minus s, then multiplied by 1, then minus 0, then everything. Yeah, so all right, so we're going to have the Laplace transform of y prime prime, which is equal to s raised to the power of 2 multiplied by the Laplace transform of y, then minus s. Okay, so I can call this equation 2. Okay, so we are done with the Laplace transform of y prime prime. The next thing is to find the Laplace transform of y prime. Let's move to the next page for that. So Laplace transform of y prime. So in this case, n is equal to 1. Okay, so this will be equal to s raised to the power of 1, then multiplied by the Laplace transform of y, then minus s raised to the power of 1 minus 1, multiplied by y of 0. Okay, so then this will be equal to, so we are going to have the Laplace transform of y prime, which is equal to s, then multiplied by the Laplace transform of y. Okay, then minus, so 1 minus 1 will give us 0, and s raised to the power of 0 is 1, so minus y of 0, and the y of 0 is 1. So we have the Laplace transform of y prime, so which is equal to s multiplied by the Laplace transform of y, then minus 1. So this is beautiful. I'm going to call this equation 3. Now the next thing we are going to do is to put equation 1 and equation 2 and 3 into equation 1. So let's do that, guys. And don't forget our equation 1, which is the Laplace transform of y prime prime, then minus the Laplace transform of y prime, then minus 2 multiplied by the Laplace transform of y, so which is equal to 0. And then we already know that the Laplace transform of y prime prime. So that one is s raised to the power of 2. So we have the following. We have s raised to the power of 2 multiplied by the Laplace transform of y. Okay, then minus s. Then for the Laplace transform of y prime, we have minus, so, and which is s multiplied by the Laplace transform of y, then minus 1, then minus 2 multiplied by the Laplace transform of y, then we can see that everything will be equal to 0. So what we have now is s raised to the power of 2 multiplied by the Laplace transform of y, then minus s. So if you open this bracket with this negative sign here, so we have a minus s multiplied by the Laplace transform of y, then plus 1 minus 2 multiplied by the Laplace transform of y, then everything is equal to 0. So the next thing I'm going to do is to add s and subtract 1 from both sides. So if I do that, I'm going to have s squared multiplied by the Laplace transform of y minus s multiplied by the Laplace transform of y, then minus 2 multiplied by the Laplace transform of y, so which is equal to s minus 1. So the next thing I'm going to do here is to factor out the Laplace transform of y. So if I factor out the Laplace transform of y, I'm going to have Laplace transform of y, then into bracket s raised to the power of 2 minus s minus 2, which is equal to s minus 1. Okay, and then the next thing I'm going to do is to divide both sides by s raised to the power of 2 minus 1. So by s raised to the power of 2 minus s minus 2, sorry, over s raised to the power of 2 minus s minus 2. So this and this will cancel each other. So we have the Laplace transform of y, so which is equal to s minus 1, then over s raised to the power of 2 minus s minus 2. So the next thing we are going to do now, to solve this differential equation completely, we have to find the inverse Laplace of both sides. Okay, so the inverse Laplace of the Laplace transform of y, so which is equal to the inverse Laplace of s minus 1 over s raised to the power of 2 minus s minus 2. So that is where we are now. So the inverse Laplace of y, so that will give us y of t. Okay, so that will give us y of t. So we have y of t, which is equal to the inverse Laplace of s minus 1 over s raised to the power of 2 minus s minus 2. So let's do that in a new page. So we have y of t is equal to the inverse Laplace of s minus 1 over s raised to the power of 2 minus s minus 2. Now the next thing I'm going to do is to factorize this denominator. Let's check. I think it can be factorized. Yeah. So we factorize s raised to the power of 2 minus s minus 2. That should give us s plus 1 multiplied by s minus 2. So this will be equal to the inverse Laplace of s minus 1 over s plus 1 multiplied by s minus 2. So the next thing we are going to do is to decompose this into partial fraction. Okay, so we can say that s minus 1 over s plus 1 multiplied by s minus 2 equals a over s plus 1 then plus b over s minus 2. So next thing we are going to do is to multiply both sides by the LCM, which is s plus 1 multiplied by s minus 2. Then if we do that, we are going to have s minus 1 equals a into bracket s minus 2 then plus b into bracket s plus 1. Then the next thing is to find the constant a and b. Then what are we going to do? So when s is equal to negative 1, let's check. When s is equal to negative 1, we are going to have negative 1 minus 1 is equal to a into bracket negative 1 negative 2 then plus b into bracket negative 1 negative 1, negative 1 plus 1, sorry. So we are going to have negative 2, minus 1 will give us negative 2, which is equal to negative 1 negative 2 will give us negative 3. We have negative 3 of a, and then negative 1 plus 1 will give us 0. Okay, so then divide both sides by negative 3, we have a is equal to 2 over 3. So we have the value of a. The next thing, let's find the value of b when s is equal to positive 2. So we are going to have 2 minus 1, which is equal to a, then into bracket 2 minus 2, then plus b into bracket 2 plus 1. 2 minus 2 will give us 0, and 2 minus 1 will give us 1. So what you have now is 1, which is equal to b, then into bracket 3. Then divide both sides by 3, so we have b is equal to 1 over 3. Okay, so we have y of t equals the inverse Laplace transform of, so a, which is 2 over 3, so we have 2 over 3, then multiply by 1 over s plus 1. Okay, then minus b, which is 1, plus b, which is 1 over 3, then multiply by 1 over s minus 2. Okay, so we apply the linearity law here, so you're going to have 2 over 3 multiplied by the inverse Laplace of 1 over s plus 1. Okay, then plus 1 over 3 multiplied by the inverse Laplace of 1 over s minus 2. Okay, so the next thing we're going to do here, I'm going to recall something for you guys. Now, recall that if you take the Laplace transform of e raised to the power of at, so this will be equal to 1 over s minus a. That is, the inverse Laplace of 1 over s minus a will be equal to e raised to the power of at. Take note of that. And then also, we take the Laplace transform of e raised to the power of negative at. So this will be equal to 1 over s plus a. That is, vice versa, we take, sorry, this is Laplace, not inverse. So vice versa, if you take the inverse Laplace of 1 over s plus a, you must get e raised to the power of negative at. Okay, so in this case, for the Laplace transform, inverse Laplace transform of 1 over s plus 1. So let me clean some parts to do that. So since we have these following formulas, so for the inverse Laplace of 1 over s plus 1. So in this case, what are we using? We are using what? This formula right here, okay, which is Laplace transform of e raised to the power of negative at. This is having plus, okay, and then what is our value of a here? So our value of a will be what? 1. So this will be equal to e raised to the power of negative t. Okay, then next one is to find the Laplace transform, inverse Laplace transform of 1 over s minus 2. So inverse Laplace transform of 1 over s minus 2. So this will be equal to, then you can use this formula right here. That is the Laplace transform of e raised to the power of at, which is equal to 1 over s minus a. So in this case, the value of a here is what? Is 2. Okay, the value of a here is 2. So we are going to have e raised to the power of 2t. Okay, so if we input those values into this part, so we have our solution, which is y of t is equal to 2 over 3 multiplied by the inverse Laplace of 1 over s plus 1, which is e raised to the power of negative t, then plus 1 over 3 multiplied by the inverse Laplace of 1 over s minus 2, which is e raised to the power of 2t. So that is the answer to that problem. Okay guys, please once again don't forget to subscribe to my channel, like my videos, comment and share. See you next time.